For decades, we've all heard the same advice: never eat before bed if you don't want to gain weight. But what if late night eating is doing far more than simply adding extra calories? What if it's quietly changing the way your body works while you're asleep? To answer that question, we have to look beyond popular diet advice and into something that's been quietly shaping your metabolism all along your internal biological clock. Here is where things become fascinating. A 500-calorie slice of pizza doesn't magically gain extra calories after sunset. Whether you eat it at 11 in the morning or 11 at night, it contains exactly the same amount of chemical energy. Yet, research suggests your body may not respond to those identical calories in exactly the same way, depending on when you eat them. So who's right? The people who insist that eating after 8 p.m. automatically turns food into body fat? Or those who argue that timing doesn't matter because a calorie is a calorie? The answer lies somewhere in between. Calories always matter. Your total daily energy intake remains the biggest factor determining whether you gain or lose weight. But meal timing may also influence how your body regulates hunger, processes nutrients, and uses energy throughout the day. The missing piece is something scientists call circadian metabolism, the roughly 24-hour rhythm that helps coordinate when your body is most prepared to digest food, regulate hormones, burn fuel, and recover. Think of your metabolism as a massive factory operating around the clock. During the day, every department is fully staffed. Fuel is unloaded, energy is produced, equipment is repaired, and the entire operation runs at full capacity. As night approaches, the factory doesn't shut down, but its priorities begin to shift. Some systems become less active. Others switch toward maintenance and recovery. Now imagine sending a truck full of supplies just as the day shift is ending. The factory can still process the shipment, but perhaps not under ideal conditions. Researchers believe something remarkably similar may be happening inside your body. To test this idea, scientists have conducted studies in metabolic ward-controlled research facilities where nearly every variable can be measured. Participants consume carefully planned meals. Calories are matched. Food quality remains the same. Physical activity is controlled. Sleep schedules are monitored. Only one variable changes, is when the meals are eaten. That simple difference has produced some intriguing results. Several controlled studies suggest that eating later in the evening may reduce levels of leptin, a hormone involved in signaling fullness, while increasing levels of ghrelin, a hormone that stimulates hunger. If that happens consistently, you may wake up feeling less satisfied and hungrier the following day, even after consuming the same number of calories. But hormones are only one part of the picture. Digesting food requires energy. Chewing, absorbing nutrients, transporting them through the bloodstream, and processing them inside your cells all burn calories. Scientists refer to this as the thermic effect of food. Here is where things get even more interesting. Several controlled clinical studies suggest that this natural calorie-burning process may be slightly less efficient when meals are eaten later at night. The difference isn't enormous, but small differences repeated every single day can add up over time. But over months or years, even small changes in energy expenditure may gradually contribute to weight gain if other factors remain unchanged. Researchers have also examined what happens inside our cells. Rather than simply counting calories, they study the molecular pathways that determine whether nutrients are more likely to be burned immediately or temporarily stored. At the cellular level, evidence suggests that during the biological night, these pathways may become somewhat less favorable for fat oxidation and relatively more favorable for energy storage. Scientists are still investigating exactly how large these effects are in everyday life, but the overall pattern has appeared in multiple controlled studies. This has led researchers to focus on something called circadian metabolic alignment matching meal timing with your body's natural biological rhythms. Instead of delivering nutrients while your metabolism is shifting toward overnight recovery, you're eating when your body appears better prepared to process them efficiently. That shift may create several downstream effects. When dinner finishes earlier, insulin has more time to return toward baseline before sleep. Lower overnight insulin may allow the body to rely slightly more on stored fat for energy while you sleep. Researchers also suggest leaving approximately 3 hours between your final meal and bedtime whenever practical. Doing so may help reduce post-meal blood sugar levels before sleep, allow insulin to decline naturally, and reduce the likelihood of acid reflux when lying down. But biology isn't the whole story. Human behavior matters just as much. By the end of the day, mental fatigue often makes self-control more difficult. At the same time, higher ghrelin levels may increase cravings not necessarily for nutritious foods, but for highly rewarding, calorie-dense foods like pizza, ice cream, cookies, or chips. The combination of fatigue, convenience, and increased appetite can make overeating much more likely, even when it wasn't originally planned. Over time, these patterns may contribute to metabolic problems beyond weight gain alone. Some large cohort studies have reported that regularly combining late-night eating with breakfast skipping is associated with a significantly higher risk of developing metabolic fatty liver disease, with some analyses reporting increases in relative risk of up to 65%. Because these are observational studies, they cannot prove that meal timing alone caused the disease, but the association has attracted considerable scientific interest. So, does eating late at night actually contribute to weight gain? Based on current evidence, it appears that it can. Not because nighttime calories contain more energy, but because eating late may reduce energy expenditure slightly, alter hunger-regulating hormones, influence metabolic pathways, and increase the likelihood of overeating. At the same time, meal timing is only one piece of the puzzle. Total calorie intake, food quality, physical activity, sleep, stress, and genetics all continue to play major roles in long-term body weight. Earlier dinners may provide the greatest benefit for people trying to lose weight, managing prediabetes, or reducing nighttime acid reflux. However, strict meal timing rules aren't appropriate for everyone. Elite athletes may benefit from nighttime nutrition to support muscle recovery. Pregnant women have unique nutritional needs, and individuals recovering from eating disorders should avoid rigid food rules that could worsen unhealthy eating behaviors. Your metabolism never truly switches off while you sleep, but it does appear to follow a daily rhythm that influences how your body responds to food. Working with that rhythm, rather than constantly fighting against it, may offer small advantages that become meaningful over months and years. But late-night eating is only half of the story. If eating closer to bedtime may reduce metabolic efficiency, what happens when you delay your very first meal instead? Could skipping breakfast actually increase fat burning, or does morning fasting create an entirely different set of metabolic trade-offs? Let's find out.